How do you get the algorithm to understand your concepts better? What happens when you lose valuable data? Feature engineering means transforming data into forms that relate properly with your underlying target learning. When correctly executed, feature engineering improves the performance of your machine learning models. In today's video, we will be discussing 8 feature engineering techniques in machine learning. Number 8. Creating features. Feature creation involves simple mathematical operations, such as aggregations to obtain the mean, median, mode, sum, or difference, and product of two values. Feature engineering for machine learning derives the feature directly from the given data. As well, when these features are chosen to relate to the primary technique, they enhance performance. Number 7. Categorical encoding. So here's the deal. Algorithms understand numerical values over categorical features, and categorical encoding is the technique that encodes categorical features into numerical values. Categorical values are converted into ones and zeros without any information loss. Elsewhere, engineers will have to scale the values to fit within the 1 and 0 conveniently. A zero mean and variance of 1 are also well received. These are applicable methods within scaling. We will share more on that shortly. Number 6. Variable transformations. Variable transformations help with normalizing unclear or incorrect data. The best known options for these transformations include logarithmic transformations, square root transformation, and Box-Cox transformation. Logarithmic transformations compress the larger numbers and expand the smaller ones. As a result, the values obtained are closer to the accurate ones. Number 5. Scaling. The feature scaling technique is also called feature normalization. The feature scaling happens when the algorithms are sensitive to the scale of the input values. The commonly used scaling processes include minimum to maximum and standardization or variance scaling. On the one hand, minimum to maximum scaling involves the rescaling values in a feature between 0 and 1. Thus, the minimum values will all take 0 and the maximum values take 1. Then the rest will be scaled to fit within the 2 points. On the other hand, standardization or variance scaling is where all data points are subtracted by their mean. Then the result is divided by the distribution's variance to arrive at a distribution with a 0 mean and variance of 1. Number 4. Handling outliers. Outliers are incredibly high or low values in the dataset that are unlikely to occur in typical scenarios. However, outliers are crucial to your predictions. Hence, securing accurate features is ideal. The various methods of handling outliers in feature engineering techniques include removal, replacing, and clapping. No, you are not teaching the machine to clap its hardware, although that would be very iconic. Someone needs to look into machine learning, but for your hardware to physically clap against each other. While we wait for the inventive genius, here is something that is already accessible. The subscribe button. Hit it now and join our family. Number 3. Feature splitting. What is feature engineering? According to American computer science professor Andrew Ng, coming up with features is difficult, time-consuming, requires expert knowledge. Applied machine learning is basically feature engineering. Yet, this is the easier option. Splitting features is basically separating the number of categories in the feature. It improves the value of the features towards the target learned. For example, date contributes to a target function more than date and time combined. So you can split the two and come up with features for them individually. What other example do you know that fits the feature splitting criteria? Could you share with us in the comments below? Number 2. Discretization. Discretization is taking a set of data and grouping them together into bins. Binning is another way to handle outliers and applies to both numerical and categorical values. Discretization also prevents data from overfitting. Moreover, there are 3 ways of grouping data in discretization. They include grouping of equal intervals, grouping based on equal frequencies, and grouping based on decision tree sorting. Let us try out a feature engineering tutorial. For example, suppose you were given a list of items sold in a shop, but one was missing. Then, you will meticulously bin the values you already have, based on one of the grouping methods, until you arrive at the most commonly occurring values for which to create a feature. Aside from binning, there are other ways to replace missing values. Sometimes you use the most commonly recurring values, and other times you use the mean. This technique is known as imputation. So let's take a look at that in more detail right now. Number 1. Imputation. Imputation involves solving missing values in data. Deleted or unfound values means missing a chunk of valuable data. Over 80% of time spent in machine learning is dedicated to feature engineering. That should explain why it is crucial to understand the concept and figure out ways to implement them. Imputation is classified into 2 types. First, categorical imputation. In the event that categorical values are missing, they are generally replaced by the most commonly occurring value in other records. Otherwise, numerical imputation is applied. For this one, missing numerical values are replaced by the mean of the corresponding value in other records. Do you know the difference between deep and machine learning? Watch here. Deep learning versus machine learning. How it works now.